You are building a sleek, cross-platform Flutter app, writing beautiful, clean Dart code that compiles down to high-performance machine code for both iOS and Android. Everything is going great until your product manager asks for one tiny feature: show the device's current battery level. You look at the Dart standard library and you realize something frustrating. There is no native system API in pure Dart. Why? Because Dart runs in its own virtual machine, completely isolated from the native hardware of the host device. To get that battery percentage, you need to talk to Android's Java or Kotlin APIs and iOS's Objective-C or Swift APIs. You are suddenly stuck between two completely different worlds, and your single code-based dream is falling apart. To solve this isolation problem, Flutter introduces a mechanism called platform channels, specifically the method channel API. Think of a method channel as a secure, bidirectional pipe passing standardized messages across a native bridge. On the Dart side, you invoke a method named getBatteryLevel with an asynchronous call. Flutter serializes this request into binary, sends it across the host boundary, and deserializes it on the native side. Here, your Kotlin code on Android or your Swift code on iOS executes the platform-specific API to grab the actual system value. Once the native OS returns the integer, the bridge packages it back up, fires it back across the channel, and resolves your Dart future. It is incredibly elegant, but writing this boilerplate code for every single native feature would drive you absolutely insane. This is precisely where the distinction between a Flutter package and a Flutter plugin becomes critical. A Flutter plugin is a specialized type of package designed specifically to wrap these native platform channels into an easy-to-use Dart API. When you install a plugin like Battery Plus or Camera, you aren't just downloading Dart code. Inside that plugin's directory, there are actual Android and iOS subfolders containing Kotlin and Swift source code. The plugin developer has already written all the native platform channel logic, compiled it, and exposed a clean, unified Dart interface. You just call battery.batteryLevel in your main codebase, and the plugin handles the messy multi-platform translation entirely under the hood without you writing a single line of native code. But what if you don't need to talk to the physical device hardware at all? What if you just want to parse a complex JSON file, manage application state, or format some dates? For these tasks, you do not need a plugin, you need a pure Dart package. Pure Dart packages contain nothing but Dart code and run entirely within the Dart virtual machine. Because they have zero native platform dependencies, they are highly portable and work instantly across iOS, Android, web, macOS, Windows, and Linux. Classic examples include HTTP for networking, Provider for state management, and Path for manipulating file paths. They simply package up reusable Dart algorithms and widgets so you don't have to reinvent the wheel. Both plugins and packages are managed by the exact same tool, the Dart Package Manager, which you configure inside your project's pubspec YAML file. When you add a dependency like Shared Preferences, which is a plugin that writes to Android's Shared Preferences and iOS's NS User Defaults, or Google Fonts, which is a pure Dart package that fetches styling assets, the CLI tool Flutter PubGet handles everything. It downloads the source files from the official repository at pub.dev and links them to your project. During compilation, the Flutter build toolchain automatically detects the native folders inside your plugins and injects them directly into the final Android Gradle build or iOS Xcode workspace compilation. When choosing third-party libraries on pub.dev, you must look closely at their platform support badges. A pure Dart package almost always supports all platforms automatically because Dart runs everywhere. However, a plugin is only as good as the native code written for it. If a plugin developer only wrote the native implementation for iOS and Android, your app will crash or fail to compile when you try to run it on web or Windows. Before importing, check the package score, verify its active maintenance, and ensure it supports every platform your app targets. By understanding this boundary between pure Dart runtime and native platform bridges, you can architect faster, more reliable cross-platform applications.